Okay, so now I'm going to do step 3, and to do that I have to build the 5-volt regulator part of this circuit. So I'm just going to use this as a reference for now. So right here, here's our 5-volt linear voltage regulator. We have a smoothing cap on the outside. We're sharing this smoothing capacitor on the input with the LM317 voltage regulator. This circuit is already built right here. So we're just going to tap off right there, which is this part, or this part of the regulator circuit, and then we're just going to put, I'm just going to put a 10 microfarad smoothing cap on the output here, and yeah, it's just grounded. So let's go ahead and start doing this. Let's make sure this thing is unplugged, which it is. I'm going to need to solder a wire because this is the output of this regulator, and I need to tap off of that. So So this is now our, what was this, about 14, 15 volts coming in. So that's about what we're getting. We're not going to need any of these. We are going to need, well, we're probably going to need some of those, but anywho, let's see how we hook this thing up. So there should be a data sheet somewhere in this book. I think it's like an 805 or something like that. Let's see. Yes, 7805. Okay, 7805. I need to find the chip package. Okay, so the chip package is right here. We're going to be using that kind of package. So we have the output, common, and input. So it's just left to right. Common is just our reference to ground. So it just goes in there and then out the other side. So it's very easy to remember. So let's see. Well, let me try to make this a little easy for you guys to see. Okay, so we have our ground coming in here. There it is. And that's the center pin, our reference to ground. And then here is our input power, voltage, which is right here. Then the output is just going to be right here between ground and that pin. So let's just stick the capacitor in there. Okay. Make sure our polarity is correct. It is. And let's just bring this over here so it's nice and easy to do what we want to do. All right. So what we have going on is we have our power coming in after the smoothing capacitor, and that's coming out from here. It goes into the input terminal on the 5-volt linear voltage regulator. Then you have your common, which is your ground, and that just gets passed through because the chip needs a reference to ground. And then we have our output with a smoothing capacitor, which is going to be, well, it is a 10 microfarad, and then it just comes out over here. So that's all we need for building the circuit. Now over here, again, I don't want to build another one of these resistors, so it's that 440 ohm resistor instead of 100 ohm. .7. All right. And then again, 1.8 kilo ohm. .767. All right. So with no load, what's V out? Let's plug it in and find out. .008 volts. All right. Let's connect the large load. Across the output. Okay, so I forgot to measure the input ripple on the 5-volt voltage regulator. So let's do that now. Wait for this sucker to warm up. I already plugged in the voltage regulator. So let's see what we have on the input. Okay. .10-volt ripple, that doesn't make too much sense. Now we need to see what the ripple is. All right, let's get the oscilloscope. Make sure we're on DC. Channel A. That's zeroed out probably enough. Let's see, can you see this? Okay, so now ground, which is right here, and then 5 volts, which, let me get a pencil. So we are set to 5 volts, and we're one line up, which means we are in fact getting 5 volts in here. Let's zoom in and try to see that ripple. Alright, so that's pretty much as zoomed in on that I can get. Let's see if let's see if I can get this in AC. There you go. Help me out. Okay, let's see. You know, there is something in there. You can kind of see it in my scope. There's a very slight ripple, but I don't think my scope can actually detect that. So I think I'm just going to have to skip that part of the lab because my scope can't see that far in. That's too bad. But it just kind of goes to show how well linear voltage regulators smooth out the ripple voltage. You know, let's take out that smoothing cap and see if we can get something out of that, just for fun. Let's let it warm up a little bit. Okay. No, you got it. Again. You see something, but no, it's not there. It's not there. Oh. You know, it's a little more pronounced. But again, it's in the 4 millivolt range, but still, it's so distorted. You can't, you can hardly see that. Oh well, worth a try. Let's put that smoothing cap back in. Let's just say it was like 4 millivolts or something like that. And let's say the discharge was like 4 or 5 milliseconds. All right, again, calculations. All right, we're going to measure. Let's connect the large load across the output and find the measured voltage. Let's just say 4.96. So this is calculate the current flow. Let's just measure it so we can have fun later and see if the calculations are correct. $11 milliamps. All right, now we change this resistor out for the 1.8 kilo ohm resistor. Then we need to measure the current and the voltage. Let's just do current now, just because. $3 milliamps. 5.01 volts. All right. That, calculations, more calculations. This one's going to be fun. All right, so remove the resistor and then do a short for 2 seconds. Then remove the short and check the voltage. Now, the older linear voltage regulators, if you did a short, they would just start smoking and stuff. It was very amusing. But a lot of the newer ones, when you do that, it has a little protection circuit built in where if it senses a short, it just kills everything. And those aren't as much, well, they're not as much fun. So we'll see which one we have by just doing a short for 2 seconds. Another fun thing would be to see, well, if it's protected, it won't get hot at all, but if it's not protected, it'll get nice and toasty, and that'll be amusing. Maybe a little toasty. Wasn't expecting that. Well, let's see. We have, oh, it came back. So it must wait a little while before it switches back on. Let's measure the voltage. 5.016. And let's do that again just for fun. After all, it's my stuff, not your stuff, so it's okay. Let's see if it really has. No, it doesn't look like it had a delay, but definitely has some sort of protection in there because the old ones were more amusing. So there we go. That's step 3.